So we were discussing about the PSW register, that is the flag register of 8051 microcontroller. So next flag of the PSW register is the overflow flag. Overflow flag indicates if there was an overflow during a signed operation. An 8-bit signed number has the range -80 hex to 7F hex. So any result out of this range causes an overflow. That is, if overflow is 1, there was an overflow in the result. And if overflow is equal to 0, there was no overflow in the result. So overflow is determined by doing XOR between the second last carry, that is C6, and the last carry C7. So after an overflow, the signed MSB of the result becomes wrong. Before going to the overflow, we need to have a thorough idea about the signed and unsigned numbers. There are two number representation, that is signed representation and unsigned number representation. Signed numbers means we have both positive numbers and the negative numbers. There are negative numbers also comes in signed representation. And in unsigned numbers, we have only the positive numbers. So if for 8-bit representation, we have 2 raised to 8, that is 256 numbers. So the numbers will be from 0 to 255. So in hex, we can represent it as 0 hex to FFX. So an 8-bit number in unsigned number representation, the range is from 00 hex to 7F hex. And in case of 8-bit signed number representation, we have 256 numbers, that is 2 raised to 8, that is 256. If the 256, that is 128 numbers will be negative numbers and 128 numbers are positive numbers. So that is 128 means the negative numbers starts from -1 to -128, that is 128 negative numbers. And the positive number will start from 0 to +127. So total 128 positive numbers and 128 negative numbers. So in hex we can represent that is -80 hex to 7F is the maximum value and the minimum value is -80. So this is an important question, that is the value for the signed numbers, that is the range of signed numbers, 8-bit signed numbers. So the range of 8-bit signed numbers will be 80 hex to 7F hex is the range of 8-bit signed numbers. So the range of negative, so the range of signed numbers is from not negative numbers, it's the range of signed numbers is from -80 hex to 7F hex. Range of signed numbers is -80 hex to 7F hex. So let's see an example, that is 10000011. The number, if it is unsigned representation, the number is 83 hex. That is, this is 1000 is 8 and 0011 is 3. So in unsigned representation, the number is 83 hex. And unsigned representation, we need to find the original value, we need to take the 2's complement of the number. So because the MSB bit, first we need to, in signed representation, we need to check the MSB bit. The MSB bit is 1. The MSB bit 1 means it's a negative number. And MSB bit is 0, that means it's a positive number. So since the MSB bit is 1 here, the number is negative. So to know the negative number, to find the negative number, we need to take the 2's complement. So to the 2's complement of the number is 01111100. So there is another, the number is -7 and 1101 is D. So -7D is the number that in signed representation, and in unsigned representation the number is 83 hex. So we have an easy method, a shortcut to take the 2's complement. So to know, all of you know that the 2's complement is the 1's complement. First we take the 1's complement and then we will add a 1 to the LSB. There is an easy method to find the 2's complement. The 2's easy method is that first we will start from the LSB. So we will write the number as it is till the first one. So the first LSB bit itself is the 1. So we write the 1 here, and then we will invert all the bits. Rest of the bits are inverted. So we will write the number as it is till from the LSB till the first one. So here the first number itself 1. So you can write 1 and all other bits are inverted. So we will write next instead of 1 we will write 0, then 0 0 we will write 1 1, and here it is 1 0 0 0. So we will write 0 1 1 1. So you will get the 2's complement. So let's see some other example. The plus 5, the plus 5, the value is 0 1 0 1. So the 2's complement, that is minus 5, is first one we will write as 1 itself, and the next one we will invert it, that is again 1, this one to 0 and this one to 1. So you get the minus 5, the value is 1 0 1 1. That is a 2's complement. So first one you write from the LSB we are taking, so till the first one we will write the number as it is. So the first LSB bit itself 1, so we write it as 1, and all other bits are inverted. 0 is inverted to 1, 1 is inverted to 0, 0 is inverted to 1. You get the 2's complement. Let's see another example so that you will get the row of it. 24 to 4, that is 0 0 1 0 is 2, 0 1 0 0 is 24. So to take the 2's complement of 24, we will start from LSB and write the number as it is till the first one. So you can write the LSB is 0, the next one 0 and 1. So the last 1 0 0 is same for the 2's complement, that is 1 0 0. And next all the bits will be inverted. So you write 1 0 0 here, and this 0 becomes 1, and all other bits are inverted. This 0 becomes 1, 1 becomes 0, 0 becomes 1, and 0 becomes 1. You get the 2's complement of 24. Is it clear? So let's see another example, that is 36. To take the 2's complement of 36, we are writing the number from LSB as it is till the first one. So your first one is 0, and next one you write 1, and all other bits will be inverted. This one is inverted to 0, and the 0 is inverted to 1, 1 to 0, this 1 to 0, this 0 to 1, and this 0 to 1. So you get the 2's complement of 36. So there is overflow flag. It indicates if there was an overflow during a signed operation, and an 8-bit signed number has the range minus 80 hex to plus 7 of hex is the range of 8-bit signed numbers. So any number out of this range, that is, if any number goes greater than 7f or it's less than minus 80, then an overflow will occur. So when an overflow occurs, the overflow flag will be set. And if the result, if the ALU operation, signed ALU operation doesn't has any overflow, that is the result is within the range, that is minus 80 hex to plus 7f hex, the overflow flag will be reset, that is 0, cleared. So if overflow is determined by doing an XOR between the second last carry, that is C6, and the last carry C7. So let's do the example. So when an overflow occurs, the MSB of the results becomes wrong. So let's take to check the flags of each. The flags that are altered during an ALU operation is the carry flag, auxiliary carry, overflow flag, and parity flag. So let's take an example, that is 31 plus 23. 31 plus 23, you will get 54 hex. So that is 31, so that is 0 0 1 1, 0 0 0 1, 31, and 23, that is 2 0 0 1 0, and 3 is 0 0 1 1. So we are doing this addition, 1 plus 1, you get 1. 0 0 with carry 1, and 1 plus 0 plus 1, you get 0 with carry 1. So 1 plus 0 plus 0, you get 1. 0 plus 0 0, 1 plus 0, that is 1. 1 plus 1, you get 0 with carry 1. 0 plus 0, you plus 1, you get 1. 0 plus 0, you get 0. So this is the result that you get after the addition. So this is the result that will be in the A register. After the ALU operation, you will get this result. So what is, we don't have any carry, so the carry flag is reset, and we don't have any auxiliary carry. There is no carry from lower nibble to higher nibble, that is auxiliary carry. So we don't have any auxiliary carry here, so the auxiliary carry is also reset. And parity, next is the parity. The parity means the number of ones in the result. So we have 3 number of ones. It's an odd parity, that means the parity flag is set. For 3 number of ones, it's an odd number, so the parity flag is set. And the overflow flag, the overflow, the number 54 is within the range, but the system that understands the overflow by XORing the last carry and the second last carry, that is the carry from C6. C6 is the carry over here, and C7 is the carry out of the MSB bit. So the C6 here, the carry is 0, and C7 is also 0. So 0 XOR 0, you get the answer 0. So the overflow flag is also 0. So let's take another example, that is 39 plus 27. You have the value 39 plus 27. Get the answer, that is 1 plus 1. You have 0 with carry 1. 1 plus 1 is again plus 0. That you get 0 with carry 1. Here also 0 with carry 1. 0 with carry 1. 0 with carry 1. You get 1 plus 1 plus 1. That is 1 with carry 1. You get 1 and 0 here. So you get the result 60. So 60, first you check the carry flag. You don't have any carry out of the MSB bit. So the carry is 0. An auxiliary carry, that is the carry from lower nibble to the higher nibble. Here you have a carry from the lower nibble to the higher nibble. So this is the auxiliary carry. There is an auxiliary carry, so the auxiliary carry flag is set. And here the parity, you have 2 number of ones in the result. So 2 number of ones means it's an odd parity, so the parity flag is also reset. Clear. Next, the overflow flag. You have the carry from C6, that is the carry from here 0, and the carry out of the MSB, that is C7, is also 0. So 0 XOR 0, you get the answer 0. Also you can see that 60 is in the range, within the range, so there is no overflow. Let's take another example, that is 42 plus 44. You get 86. You know that 86, that is out of the range, that is 86 is greater than 7 up. So it is 42 for 2 and 44, that is 4 plus 4 and 4, that is 42 plus 44. You get the answer 0 plus 0 0, 1 plus 0 1, 0 plus 1 1, 0 plus 0 0, 0 plus 0 0, 0 plus 0 0, 1 plus 1 0 with carry 1, and 0 plus 0 you get 1, plus 1 you get 1. So here you can see that there is no carry out of the MSB bit, so the carry flag is 0. And you can see there is no carry from the lower nibble to the higher nibble, so the auxiliary carry is also 0. And the parity, you can see 1 2 3, 3 number of ones in the result, so the parity is 1. And to check the overflow flag, you have a C6 is 1, that is carry over here, that is from 6th bit to the 7th bit, this position, that is second last carry, this is 1, and the last carry it is 0. So you have 0 XOR 1, you get the answer 1. So there is the overflow flag will be set. So the result 86 is out of the range for a signed number as it becomes greater than plus 7f. So such an event is called signed overflow. In such case, the number of the result gives a wrong sign. MSB of the result gives a wrong sign. So the result is positive. The MSB bit 1 indicates that the result is negative. So overflow is determined by doing XOR between the second last carry and the last carry. Here the second last carry that is coming out into the MSB bit is 1, and the final carry that is going out of the MSB bit is 0. So 1 XOR 0, you get 1.